we have learned yesterday and the day before is we apply a single transformation to, or one type of transformation to the graph. So for example, we only have dilation. Dilation from the x-axis, which is changing y, and dilation from the y-axis, which is changing x. Or we have translation to the positive direction in the x-axis for 2 units and translate 1 unit in the negative direction of y-axis. That's for translation. Or we have reflecting the x-axis and then reflecting the y-axis is changing x and y. So today what we're going to learn is we combine everything together. We have multiple stage like for transformations and everything with a particular order. Okay, order is very important for transformation. Okay, so what order they give you, see 1, 2, 3, 4, 5, 6, you need to follow that order. Okay, you need to follow that order. Okay, so let's have a look at this question, what type this question belongs to. So question 2 says, what is the image equation for this quadratic after the following transformation in this particular order? Okay, in this particular order, you can't do 1 and then 3 and then 4 and 5. So in this order, we trying to have this original function. After this transformation, we want to see what's the resultant function. So this type is, well, we have 1, 2, and 3. So 1, we have y equals to x plus 2 squared. Okay, because it's original, we have x and y. What we interested in this is this question mark. Okay, what we interested in is this question mark. So now you know we need to write 2 equations. X dash equals to some x, y dash equals to some y, according to the word they give us, like the description, the transformation description here. So what we can write now, before it's really easy, dilation by a factor of 2 from the x-axis, y dash equals to 2y, done. Now we have multiple states, what we should do. So one thing you need to write is the calculation order should be the same as your transformation order. Okay, I'll tell you what that means, but you write this down first. The calculation order will be the same as your transformation order. So how you calculate things in one equation, that will be the same order as your transformation. So let's have a look in this case. The first one says translation 2 units in the positive direction of x-axis. What you can write? Just go this one sentence, what you can write. Translate 2 units in the positive direction of x-axis. X dash. Yep, x dash equals to x plus 2. Okay, for maths, we like numbers, equations. We don't like wording. So we need to change all this word by math representation. Okay, that's the first thing. Second, what that's, oh well, don't put bracket yet. I will tell you what that means later. Okay, the next one is dilation by a factor of a half from y-axis. What is changing? X is changing. So it's a half, right? It's a half of the original. But your original one become x plus 2. Also remember, your calculation order must be the same as your transformation order. Therefore, we need to bracket this and then times that by a half. It will be the same as a half x. But your x now is x plus 2. Like it changed already. Okay, changed already. So we times a half on that. Okay, next thing. Reflect in the y-axis. What's happening? What changed? X changed. So it's the negative of original, right? So you will negative this as well. So you negative the whole thing. So the first thing happened is x plus 2. The second thing happened is times by a half. The third thing happened is negative that. Okay, that's what happens to x. Okay, let's look at 4. 4 says reflection in the x-axis. What has been changed? So what I can write? Y dash equals to negative y. Okay, that's according to 4 what we can have. 5. Translate 1 unit down. Changing y as well. So moving down by 1 unit. So we just minus 1 here because the negative y happened first and then moving down. So calculation order will be the same as the transformation order. We calculate minus y first and then minus 1. Okay, and then minus 1. And the last one says dilation by a factor of 4 from the x-axis. What has been changed? Y again. So you times y by 4, but is this times by 4 because minus y first and then minus 1 and last is times by 4. Okay, done. So this is actually to number 2, right? This is number 2, what we have. That's what we have. Okay, anyone tell me what we should do after that step? We want to achieve x dash y dash. So what we should do? How? Can I sub indirectly? Rearrange it to make what to be the subject? X and y to be the subject, to replace this y and to replace this x by x dash and y dash. So the next thing we need to do is rearrange it. So by rearranging it, we can times minus 2. On both sides, we have x plus 2, right? Minus 2, and then x will be the same as minus 2x dash minus 2. For the y side, it's a quarter y dash equals to minus y minus 1. A quarter y dash plus 1 equals to minus y. So y equals to minus a quarter y dash minus 1. Okay, so we use this one and this one to do the substitution. Okay, step number 1, step number 2, and step number 3 will be the substitution. We're trying to sub things in. So the y will become minus a quarter y dash minus 1. And your x will be changed to minus 2x dash minus 2. And don't forget you have a plus 2 originally. So that's the position for y, that's the position for x. Right? And you just rearrange it. So what we have is minus a quarter y dash equals to, well, inside is a minus 2x dash and this squared. Okay, this 2 get cancelled. We plus the 1 to that side. Okay, we times minus 4 on both sides. So that's a minus 4 times by 4x dash squared minus 4. Right, this minus gets squared, become positive 4x squared, and you times minus 4 on both sides, you have minus 4 here. Then y equals to minus 16x squared minus 4. Okay, y equals to minus 16x squared minus 4. Right, that's what end up with. You can get rid of the dash. Okay, you can get rid of the dash. So this page, okay, this page is talk about the question, give you the original one, give you the resultant, ask you for resultant function and give you the transformation description. So give you 1 and 2, ask for 3. So this is the type of question we have on this page. So nothing really changed. The x dash y dash become more complex. You just need to keep writing things on it according to all this different kind of transformation. But the order is very important. Your order of calculation must be the same as the order of the transformation happened. So that's what we can write. So the very important thing is to write the stage 1 correctly. Okay, stage 1 correctly. Any questions to this one? If you don't have any questions, can you go to the previous page? Okay, the previous page, I want to change the question. I don't want to have part A, part B, and part C. So let's read the question together and cross out the part I don't want. the function of g is obtained from the graph of function rule fx equals to x squared by a translation of 3 units in the positive direction of x-axis and the translation 1 unit in the negative direction of y-axis. Okay, cross out that. I don't want that. Write down the rule for g. I don't want the rule for g yet. And then I don't want b. Okay, I don't want a, b, and c. So keep going. Then I just combine everything together. Okay, then the graph is dilate. I just combine everything. Dilate by a factor of a half. Okay, so just keep going with the transformation. I don't want the result. Then the graph is dilate by a factor of a half from the y-axis and then a reflection in the x-axis. I don't want the last sentence, so I don't need the rule. Then by a translation of 1 unit in the negative direction of y-axis and the dilation from the x-axis of a factor of a third. Then write down the rule for g. Okay, write down the rule for g. So I want all this transformation happen at the same time. I don't want stage by stage. I want everything happen at the same time. So it's exactly the same as this question. So 6 things happens in a row. Okay, all happen together. Well, it's nothing really changed. It's just like, oh, can you see all the transformations? Make them happen in order, and I want the final result. I want the final result directly. So the graph of g is obtained from the graph of that. Translate 3 units to the right, then translate 1 unit down, and then dilate by a factor of a half from the y-axis by a reflection in the x-axis, and then a translation further 1 unit down in the y-axis, and then a dilation by a factor of a third from the x-axis. Write down the final result. Okay, I want the final result. So give you 10 minutes to think about that and then trying to do it. This question is exactly the same as what we do here. Okay, those 2 questions are identical. Nothing changed. Okay, have a discussion, trying to do it by yourself. If you can't do it, ask for help. The graph of g is obtained from the function fx equals to x squared. So what I will do for this one, let's say 1, 2, and 3. I'm looking for number 3, which is the result. I don't want to use fx. I will use y equals to x squared because I want x and y. And then I want to see what's in the middle according to this language, like these words. The first thing we did is a translation of 3 units in the positive direction of x-axis. So 3 in the positive direction, your new point will be the old point plus 3. If the original point is 0, 0, so the after 3 units in the positive direction of x-axis is 3, 0. So the new point is the old point plus by 3. Then translate 1 unit in the negative direction of y-axis. So y dash will be y minus 1. Okay, that's the first thing. And the next sentence says, then the graph is dilated by a factor of half from the x-axis. It's changing the y-axis, it's changing the x value. So this number will be times by a half. Okay, dilated by a factor of half from the y-axis is changing x. So it's a half times the result. And the reflection in the x-axis is changing the y value. We will minus the y. Okay, we all times by minus 1, it will be the same. So we minus the y value. Then the next thing is, by a translation of 1 unit in the negative direction of y-axis, we further minus 1 here. Okay, can you see it's still the same as your calculation order? Minus 1 times negative 1 and then minus 1. And we have a dilation from the x-axis by a factor of a third, changing y value. So this whole thing needs to be times by a third. Okay, everything previously will be times by a third. So that's the two equations we should have, okay, for that box. So that's the two equations we should have. Now you know I want to replace y and replace x by x dash and y dash. We need to rearrange it in order to substitute. So my x equals to 2x dash minus 3. Okay, my x will be 2x dash minus 3. Y is a little bit annoying. I'll go step by step. Okay, so I'll times the 3 on both sides first. So 3y dash equals to, okay, let's see what happens in this square bracket. We have minus y plus 1 and then minus 1. Okay, if we expand it. So the plus 1 and minus 1 get cancelled. So the plus 1 minus 1 get cancelled. So my y equals to minus 3y dash. Okay, my y equals to minus 3y dash. Then next step is substitution. Okay, we substitute things in. What we should substitute is y equals to x squared. So y is minus 3y dash. X is 2x dash minus 3 and then squared. Alright, I want to talk about the skew for that. I want to make it into a turning point form. I want to make that into a turning point form. Like turning point form is x minus h squared plus k, right? X minus h squared plus k. I want a single x. I want a single x in the bracket. But everyone needs to listen to this because no one really did it. I want a single x in the bracket. So what I can do, I leave the minus 3 first on that side. Just keep it there. Okay, this in the bracket, I can make x bracket x dash minus 3 over 2. And then that will be squared. Okay, and then that will be squared. Trying to make a single x in the bracket. I will tell you why tomorrow because we need this skill. And the next thing is we will square both things. So 4x dash minus 3 over 2 squared. So the 2 actually will become a 4 by exponential rule. Okay, so it's 2 times x dash minus 3 over 2, whole thing squared. 2 will be squared, the bracket will be squared. And then the last step will be y dash equals to, well, I can make y equals to minus 4 over 3 x minus 3 over 2 squared. That's my gx. Okay, answer the question in the way they want. I won't say if you leave like this it's wrong. Okay, I won't say it's wrong, but I just think there's a better format we can have, and also we need to use this skill tomorrow to talk about like the transformation. So that's what we will have. Okay, that's my final answer. I think a lot of you stop at that step and you divide negative 3 on both sides. You have negative a third times that. But actually I can turn that into a turning point form. I can see the turning point is 3 over 2 comma 0 and is a downwards like set phase quadratic. Okay, set phase quadratic. Okay, I want to change the question. Well, tomorrow I don't have enough time, so I will change some questions here. Can you just help me to write down that? For example 3, again, I want part A and part B. Part A is dilate by a factor of what? From the let me see, from the x-axis, then translate by, like, you talk about the translation after that. Which axis I'm not defined that, you do that by yourself. So you talk about the translation. And B is dilate by a factor of what? From the y-axis. Then translate by what? Okay, same as before, like when we do the square root. I said if you can dilate by one direction, you can definitely dilate by another direction. So if you can dilate by x, you can definitely dilate by y by a different factor, or you can even dilate by both x and y. So that's what we learned yesterday. So this question again, I want to try to investigate on this as well. Okay, trying to investigate on this as well. And because this question was spent most of the time, I want to do one example with you today, and you try example 2 by yourself, and then we just focus on 3 and 4 tomorrow. Otherwise, I can't finish it. So this type, okay, this page, the previous page is give you the transformation, give you the original question, and ask you for what you will get in the end. And for this page, what we get is determine the transformation. So you get 1 and 3, you ask for 2. So 1, 2, and 3. So ask for that, I get the other 2. Okay, I can finish that in 2 minutes. Really quick, the first one. So again, it will be the same. You need to recognize what is the formula, like what is the rule, like what is the function. This function is a square root function. What I want to keep on the right hand side is only the square root and the thing under it. So that's in a perfect form. Okay, that's in a perfect form. So I need to distinguish between the before and after. So that's the before, that's the after. Okay, y dash and x dash to distinguish. Remember, step number 2, I always need x dash equals to some x and y dash equals to some y. That's what we can get from number 2. Okay, now I will equalize both sides. Y equals to y dash. X equals to 5x dash minus 2. Can I talk about transformations at this stage? Can I really say this is a dilation by factor 5 and then move down by 2? No, what I need to do? Make x dash to be the subject, to rearrange it, to see the new point equals to old point what? Okay, what happens to the old point? So, okay, this is the important part I want to talk about. X dash will equals to 1 on 5 times by x plus 2. Can you see it? We plus the 2 and times 1 on 5. But I can expand it. Okay, what's the difference between those two? Let's say that's number 1, that's number 2. Do you remember what's the order we should describe transformation by ourselves? DRT order. Dilation, reflection, and translation. And also I said the calculation order will be the same as your transformation order. So from number 1, okay, from number 1, what I can say is translate 2 units to the right. Then, okay, we need the then dilate by a factor of 1 on 5 from the y-axis. Okay, that's what we can get from the first one. Because your calculation order must be the same as your transformation order. How do we calculate this? We plus the 2 first and then times by 1/5. So it's moved to the right by 2 and then dilate by 1/5. Okay, I'll let you know this is a right answer. This is a right answer. Nothing wrong. Okay, nothing wrong. But if we really want to follow the DRT order, I will use number 2. So number 2 will give me dilation by a factor of 1/5 from the y-axis. Then translate 2/5 units to the right. Okay, 2-step as well, but this dilation happened first. The dilation will be 1/5 and then translate 2/5. But if we translate first, we'll translate 2 and then dilate by 1/5. Okay, that's what I said. If you change the order, the answer will be different. Yeah?
Have you noticed you translated 2/5 units to the right and not 2/5 units up?
Because it's the x. It's the thing happened to x, not happen to y. If it happened to y, it's move up and down. Yeah? Any questions to that? Like, let's talk about the order, how we should describe it. The preferred one will be number 2. Okay, the preferred one will be number 2, but number 1 is right as well. But if you can always keep a habit to expand things, okay, we need to expand. If we can expand everything, we will have the DRT order. Okay, we will have the DRT order. If we keep things in factorized form, you will have the translation first and then dilation, because you add and subtract first. So that's what I want to mention today. Okay, that's what I want to mention today. Tomorrow we'll learn the same thing, but I want to get a start here. And you have like 20 minutes left. I want you to try example 2 first, and then you can do your homework exercise. Any questions to that question?